Time to solve the last problem on the free fall sheet. This one's a little trickier than the others, so let's see what the picture looks like and see why two answers are possible. So let's see what we have. Here's our start point, and we're told it is thrown up at 18.8 meters per second. Now, let's see what's going on. Why are two answers possible? It goes up, and it can be at the end point, 7.88 meters here. But it could also be at that same point after it reaches its peak on its way down. So there are 2 points at which the ball can be 7.88 meters above the point where it starts. Remember, this is a displacement. So the displacement on the way up and on the way down is the same. The distance traveled is different, but the displacement is the same. So now let's see how we can figure this out. I'm going to call y up because that's the direction of the initial velocity, and it's time to make our list. We know v0, 18.8 meters per second. We are told delta y, again, both cases, 7.88 meters. Acceleration, since g points down, opposite to our axis, negative g. And we are looking for time. And then there's v and v bar. So we know 2 times are possible. We do have an equation that will give us 2 times. It is this one. Delta y equals v0t plus 1/2 at squared. We know we can get 2 times out of this because of the t squared, the nature of the quadratics. Anytime you are using this equation and solving for time, there's a possibility of having to deal with quadratics, and it is based on if all the terms are non-zero. And in this case, they are. Let's just substitute them in and see what we have. 7.88 meters equals 18.8 meters per second t plus 1/2 negative 9.80 meters per second squared t squared. We have all non-zero terms, therefore we are going to have to deal with quadratics. Now, when we deal with quadratics in here, we will be using the quadratic formula. But before you can do that, we have to remember that quadratics need to be put in standard form. And that form is this: ax squared plus bx plus c equals 0. This is the coefficient of the squared term is a, the coefficient of the linear term is b, and the constant term is c. It is traditional to make sure the coefficient of the squared terms is positive in this equation. It doesn't have to be. So let us write this equation in this form, and we'll drop the units off to make it a little easier to read. When you put it in this form, you should see that we would get this: 4.90 t squared minus 18.8 t plus 7.88 equals 0. And these are the coefficients now. A, B, notice the negative goes along with the 18.8, C. And to solve this, we have to use the quadratic formula. It is on your equation sheet, but it gives the roots of the equation. x1, x2, negative b plus or minus, that's where our 2 answers come in, the square root of b squared minus 4ac, that entire thing over 2a. Now, we're not solving for x here, we're solving for time, but it is the same concept. So let's see what we end up with. The roots, t1, t2, equals negative b, so that's 18.8, plus or minus negative 18.8. Remember, square the negative. That's b squared minus 4 times 4.90 times 7.88. And that entire quantity, not just the square root, over 2a, which is 2 times 4.90. So as we keep going, T1, T2, 18.8, plus or minus that pile under the square root, 14.1, all over 9.80. And this is where we get our 2 times. 18.8 plus 14.1 over 9.8, 18.8 minus 14.1 over 9.8. And when we solve these, we end up with these times. T1, 3.36 seconds. T2, 0.480 seconds. This obviously has to be the time on the way up. This obviously has to be the time on the way down. So in this case, both times make sense because the ball can be at the same displacement at 2 points in time.